Alright, I wanted to do a quick video. A couple people wanted me to explain a little more about the actual control board that I built. First, you might notice that I've tied down these wires pretty nicely, so they stay out of the way. It allows the stuff to move freely without snagging, which was an issue I was starting to have. So anyway, it's a really simple board. I soldered it myself. There's a whole bunch of magnet wire underneath the bottom that links traces and stuff together. This is one of those cheap $2.50 Radio Shack prototyping boards. It's just got a couple common rails, couple short common rails, and then just a bunch of solder pad holes that are isolated from each other. So what I've got on this thing is the workhorse here is this chip here. This is an Atmega 328P. It's in the 24 pin dip chip format. These are popular in the Arduino Uno prototyping boards that you've probably seen around if you're into electronics. I've taken just the chip and not using the Arduino environment at all in this, but the chip is actually a pretty decent chip. It's got all kinds of I/O channels and timers and all kinds of great stuff on it. So anyway, so this guy right here is the linear voltage regulator. It's a LM7805 linear voltage regulator, and it regulates the input, which comes in here, down to 5 volts. Now I'm using a 2-cell LiPo battery. Is what I've designed this for. A 2-cell LiPo battery will put out a nominal voltage of 7.4 volts. This has a voltage dropout of about a single volt, so I can get it down to about 6.4-ish volts. It'll still work down to about 6.3 and 6.2 volts, but when the battery gets down to that level, I don't want it to work anyway, and so I'll go into that a little bit later. This guy here looks like a voltage regulator. This is actually a big fat P-channel MOSFET rated for like 60 amps or something like that. It's a pretty beefy P-channel MOSFET. The purpose of this guy here is to protect in case I put the battery in backwards. If I put the battery in backwards, I will destroy the voltage regulator. But not with this. This guy here is wired in such a way that if I put the battery in backwards, the reference voltage becomes the positive rail of it, and therefore the running voltage is negative. I have the gate of this connected to the ground, which is positive voltage, because the gate is much higher than the supply voltage, which is actually negative. You have an impossible scenario in which the source and drain won't connect. So basically, this will close off and prevent the circuit from working at all if a battery is plugged in backwards. So that's what this guy's here. This is a 0.1 UF ceramic capacitor. It's just for filtering. I've got a little 10 UF capacitor here for basically buffering supply voltage. Resistors for the LEDs, a little on and off switch. This is a header for the ISP programmer that I connect to this to actually program the chip. All of these are the connections to the 8 servos. They're plugged into some simple headers that I soldered on. This guy right here is a little reset button, nothing fancy. There's on the other side of this heat sink that's on this guy is just a power LED, and that's pretty much it. Now I do have, going back to that supply voltage situation where I don't want it to work when it drops below 6.4 volts or so, I have, you can actually see these two resistors here, this guy and this guy, form a voltage divider. I believe this is 680,000 ohms. This is 100k ohms. But anyway, it does a voltage divider down so that I can measure the supply voltage, because the Arduino analog input pins are only 5 volt tolerant. So if I give it 7.4 volts on an analog pin so that I can read what the voltage is, I will kill that pin. So this divides it down, and then I have to basically inside of the chip do the math to convert it back up to figure out what the voltage is. So I have that connected to an analog input pin. I calculate the voltage. When I figure out the voltage, if it's below 6.2, I start flashing this little LED, just cut off the signal to the servos so it stops using juice, and then ultimately just shut everything down to the bare bones minimum operation so that I don't drain the battery below 6 volts, because you cannot drain a LiPo battery below 3 volts per cell. and a 2S LiPo battery. It's two cells in series, so got to protect against that. And that's really it. There's not a whole lot else to this board. I guess you consider this version 1 of the board. I have a couple issues with it. The first of which is I don't like this battery connector. So if you see this in a new video, this won't be here anymore. I'm going to put some 2 standoff pins here. Basically, this stress of going like this is breaking the pins, or they're breaking the wire off. I thought I might try and do this so I could wrap it around underneath, but yeah, it didn't work out so well. And I need a few more caps, I think. I need a big giant supply cap, or decoupling cap is what they're actually properly called. Big giant decoupling cap on the microcontroller, so that it smooths out the current. And I need a big giant fat coupling cap right here next to the servo supply lines, because when all 8 of these servos go at once, it pulls a ton of current through the battery, through the regulator, and it can't keep up. And so the current drops. Well, to maintain the current, the voltage drops, and we have all kinds of problems, and I lose the chip kind of resets itself. So those are things I'm going to make some changes to. I'll just kind of flip this guy over here so you can see the underneath of it. I just have this big giant standoff that the board mounts to, that screws into this backbone here. Got all the wires tie wrapped down here. Got 8 of these, I believe they're called Tower Pro 9-gram micro servos. I think the model number is like SG90. I got a bag of 12 of them for like 15 bucks off eBay. They work really well. They're cheap. They're fun to play with, and you break them, it's not a whole lot of money you've lost. And aside from that, you know, there's the shoulders and the hips, I guess, and the legs. This is the brace to the backbone, and works pretty well. I like it a lot. So anyway, it's a little more in depth of what's on this board here, and hope you enjoyed it. Thank you.